Okay, so again, the first thing, make sure you know what all the equations are for in this unit. None of them are very difficult. All of them are basically going to be plug and chug type things. Some of them have a few more variables like this one here or this one here, but they're all basically plug numbers in and solve. But make sure you know what each of them are, and that way you know what to use them for. So here we go, number 14. So the temperature of 5 moles of gas increases by 50 degrees Celsius. So I bolded Celsius. That tells me right off the bat, okay, this needs to be in Kelvin, not in Celsius. So the equation for Kelvin is Kelvin equals the Celsius temp plus 273. So the change in temp is 50, which is fine. This is going to be the change in temperature. So the change in Kelvin, so 50 plus 273 is 323. And that's the change in temperature. So it's important to make note that it's a change in temperature, not just a temperature. So in other words, the temperature of the gas isn't 323 Kelvin. The temperature of the gas is 323 Kelvin higher than what it was. And honestly, it doesn't matter how much higher. It doesn't matter what the starting value was. Okay, so then A wants to know what's the change in internal energy. So as soon as I read that problem, I look to myself and I say to myself, what equation's got change in internal energy? So internal energy is delta U. So there's only two equations that have that. That's the change in internal energy equation and the first law of thermodynamics. So I'm thinking to myself, okay, if it just wants to know how much my kinetic energy or my internal energy changes by, that's probably this guy. So let's see if we got all the variables for that we need. So we're solving for change in internal energy. Okay, the problem tells me the number of moles. And moles is kind of a measure of how much mass a gas has. That's not exactly what it is, but that's close enough for our purposes. It also tells me the change in temperature, which we just found, which was 323 Kelvin. So now I'm ready to plug my numbers in and solve. So the change in internal energy So delta U equals 3/2 times N, which is 5 moles, times R, which is given, 8.314, times the temperature change, which was 323. And energy is always measured in joules, and this is no different. All right. So that takes care of A. There's my delta U value. So now for B, we'll wrap this up here. So now for B, B says, assuming no heat is gained or lost, how much work is done, and is it work done on or work done by the gas? Okay, so if no heat is transferred, that means Q is 0. So Q is heat. Be careful. heat is transfer of energy. It's not the amount of energy. So a lot of times people think of if it has no heat, then it has no energy. That's not true. You're thinking about temperature versus heat. So an object has temperature. It doesn't have heat. It transfers heat. It doesn't transfer temperature. So temperature is what an object has. Heat is what an object transfers. Okay? So there's no heat transferred in this problem. So the equation is delta U plus W. So delta U, the internal energy is increasing. So Q equals delta U plus W. So no heat transferred. The internal energy changes by 20,140.7 plus work. So you'd subtract that to the other side, and the work is negative 20,140.7 joules. Mason, I realize now I told you the wrong thing. I was thinking about the wrong problem. So the last question is it work done on or work done by? Work done on is going to be negative. Work done by is going to be positive. So this is negative, which means it's work done on. And if you're wondering what kind of, what would be happening for this to happen, this would be compression. So this would be the compression of a car engine. When work is done on the gas, the temperature, internal energy of the gas is going to increase, but it won't necessarily transfer heat into it. But the energy will done. So this is work done on in this case. All right, before we go, let me tell you the other problems that I thought were really important to work on. So if you don't do any other problems other than these are the ones I would do.